The cosmos is filled with realities so strange they could be mistaken for science fiction, yet they are entirely real. I invite you to embark on an exploration of this universe, a place of silent stellar explosions, unbelievable worlds, and events that are only now entering the grasp of our scientific knowledge. I want you to set your mind free to journey beyond its usual limits, discovering tales that feel fictional, but are unfolding in the vastness of space at this very moment. Our inherent curiosity knows no bounds. For countless ages, humanity has looked to the heavens, wondering about the realms beyond our world. The universe is more than just a source of awe. Its immense complexity serves as a cosmic theater for the epic sagas of birth and annihilation. Each point of light you see in the night sky is a messenger from the past, bearing witness to cosmic dramas that occurred millennia or even eons ago. It's challenging for us to truly grasp the sheer scale of the cosmos. Consider the ocean. What appears to be a boundless surface hides a world of currents, organisms, and secrets we've only just started to explore. In the same way, the universe is teeming with remarkable occurrences that defy our current comprehension, from the birth of stars and nebulae to the titanic clashes of entire galaxies, offering lessons in every quadrant. You might ask what space actually contains. While calling it a vacuum seems straightforward, that description is far from complete. In reality, the cosmos is permeated with gas, interstellar dust, radiant energy, and the gravitational fields that mold all of existence. A hypothetical journey through this universe would reveal that each star, planet, and black hole is a single component in a grand, interconnected puzzle of unimaginable scope. Delving into the universe does more than just supply us with answers. It sparks even more profound questions. You find yourself wondering why certain stars endure for eons, while others detonate in a fleeting, brilliant flash. We're driven to ask what sculpts the galaxies, and how they are woven together across the cosmic tapestry. These inquiries propel us forward on a thrilling expedition where each finding unlocks yet another enigma. Throughout this exploration, it's crucial to recognize that you are a small yet meaningful component of this immense cosmos. The very atoms composing your body were created in the core of ancient stars, establishing an unbreakable connection between us and everything in existence. Gazing into a clear night sky serves as a potent reminder that you are not isolated, but rather an integral piece of something far grander. The universe's splendor is rooted in its incredible variety. From worlds circling distant suns to galactic clusters gathered in the immense dark, each celestial body contributes to a magnificent cosmic symphony. With every step we take toward greater comprehension, we gain a deeper appreciation for the intricate design and fundamental harmony of the natural order. With that, I want to formally invite you to accompany me on this investigative journey. As we peel back the layers of cosmic secrets, you'll come across phenomena that defy conventional thinking and fuel the desire for further discovery. Our guides on this path will be science, curiosity, and imagination, and by using them, we will together unearth the marvels the universe holds in store. Every stage of our expedition will bring us to a new frontier, a place where suns burn with their own fire and worlds trace their orbital paths. You will be introduced to black holes, far-flung galaxies, and the elusive substance known as dark matter, which constitutes the bulk of our cosmos but stays invisible to us. We will also examine the entire lifespan of a star, from its formation in a nebula to its cataclysmic end, and see how these cycles forge the universe itself. As we move forward, it's vital to keep in mind that the quest for understanding has no end. Each new finding inevitably gives rise to fresh inquiries, and every solution reveals further puzzles to solve. Think of the universe as an unfinished book awaiting new readers, where every single one of us has the opportunity to contribute a new page to its unfolding narrative. On this voyage, you will not just observe the magnificence of the universe, but also contemplate your own position within it. To comprehend the cosmos is to be moved by its beauty, and to acknowledge the delicate nature of our own existence. Within the immensity of space, each life may be a transient flicker, yet every single flicker is an essential piece of this remarkable entirety. And so, with no more delay, let's get ready to immerse ourselves in the marvels of the cosmos. Each star you see is a lighthouse of information, and every question you formulate is a move closer to grasping what it truly signifies to belong to this expansive and breathtaking universe. Within the immense ocean of space, you can find the captivating phenomena responsible for creating stars, nebulae. These colossal formations of gas and dust act like cosmic sculptors, fashioning the luminous orbs that illuminate our heavens. The secret to this breathtaking process of stellar birth can be found in the complex interplay between gravity and matter. The primary component of nebulae is hydrogen, which is both the most basic and the most plentiful element in the cosmos. To visualize this, picture a massive balloon filled with helium that is gradually losing its air. As the gas inside cools down, its particles start to aggregate, creating small groupings in a process known as condensation, the foundational stage of a star's creation. So, what follows this initial step? Once these gaseous clumps achieve sufficient density, the force of gravity takes on a central role. More matter draws together, causing a buildup of pressure at the core and a corresponding surge in temperature. You can compare this to kneading dough. The more you compress it, the warmer it becomes. This generation of heat is absolutely essential for igniting the birth of a new star. When the core temperature inside the nebula soars to millions of degrees, the stage is set for nuclear fusion to commence. You could think of fusion as a kind of celestial celebration, where hydrogen nuclei merge to become helium and unleash a tremendous volume of energy in the process. It is this released energy that you perceive as a star's light and warmth, the very forces that sustain its brilliant existence. A star's existence, however, is not without end. As it progressively burns through its primary fuel source, hydrogen, it starts to undergo a transformation. Consider a lamp that is beginning to run low on battery. Its illumination will slowly start to fade. The stars, those brilliant specks of light in the night sky, lead remarkably complex lives that are far more dynamic than what you can perceive. Have you ever paused to consider their origins? The entire life cycle of a star is an epic narrative of drama and metamorphosis, beginning the moment it coalesces from colossal clouds of gas and dust. A star's journey originates within a nebula, an immense cloud composed of hydrogen, helium, and other elements. It is here that gravity, the universe's fundamental architect, begins its work, drawing material together with incredible force. This gravitational collapse generates immense pressure, triggering the process of star formation and culminating in the ignition of thermonuclear fusion in the star's core. This fusion process, where hydrogen atoms combine to form helium, unleashes a tremendous amount of energy, and signals the true birth of a young, hot, and luminous star. It's astonishing to realize that the very same reaction powering our own sun is replicated in billions of other stars throughout the cosmos. For much of its existence, which for a star like our sun can last about 10 billion years, it maintains a delicate equilibrium between the inward pull of gravity and the outward pressure from its nuclear engine. But what unfolds when a star exhausts its primary fuel source? This is where the story takes an even more compelling turn. After depleting the hydrogen in its core, the star begins to swell dramatically, transforming into what is known as a red giant. In this bloated state, it can expand to such a size that it engulfs any nearby planets, a fate that awaits Mercury and Venus in our own solar system. Yet this is not the end, but simply another transformation. Following this period of expansion, the star will cast off its outer layers, giving rise to a planetary nebula. This breathtaking spectacle of light and color stands as the beautiful legacy left by many stars. At the heart of it all, a dense, hot remnant called a white dwarf remains, destined to slowly cool over billions of years. However, not every star follows this particular life cycle. Stars that are significantly more massive than our Sun are destined for a far more violent end. They conclude their lives as supernovae, titanic explosions so powerful they can briefly outshine their entire host galaxy. Can you even begin to comprehend the sheer scale of witnessing such a cosmic event? These cataclysmic events are more than just dazzling light shows. They play a critical role in cosmic creation. As a supernova detonates, it forges and scatters heavy elements across space, enriching the interstellar medium. These materials become the essential building blocks for the next generation of stars and planets, potentially seeding other worlds with the ingredients for life. The profound connection between life and death in the cosmos is truly captivating. The demise of one star can directly trigger the formation of new nebulae, where matter once again gathers to initiate the birth of another. This perpetual cycle of existence, life, death, and rebirth, has repeated for billions of years, sculpting a universe that is in a state of constant evolution. Furthermore, stars are often part of larger stellar systems, sharing their cosmic neighborhood with other celestial bodies. These interactions can result in phenomena like gravitational capture, where one star's immense pull can draw another into its orbit. This celestial dance serves as a powerful reminder that nothing in the universe truly exists in isolation. Everything is connected through the intricate web of gravity. So, what fundamental purpose do these stars serve in the grand scheme of the cosmos? Beyond illuminating the night sky, their most crucial contribution is providing the essential elements for life itself. Through the intense process of nuclear fusion, stars forge heavier elements such as carbon, oxygen, and iron, all of which are indispensable for the formation of planets and, eventually, life as you know it. As stars undergo their cycles of birth, life, and death, they are both creators and destroyers, actively shaping the universe around them. Every single star you observe in the sky is a testament to this grand process, a living narrative of creation and transformation. And though stars might appear eternal, their life cycle is a profound reminder that everything in the cosmos is in a perpetual state of change. The next time you gaze up at the starry sky, take a moment to remember that each of those luminous points is the culmination of millions of years of history. From the detonation of a supernova to the coalescence of a new nebula, the universe is brimming with wonders that invite our exploration. Star formation is not merely a beautiful phenomenon. It is evidence of the profound complexity and interconnectedness that defines our reality, reminding you that your life is deeply intertwined with the history of the stars. Some stars you see are youthful and brilliant, while others are in their final phase, leaving behind trails of gas and dust that will seed new celestial bodies. Exploring the life cycle of stars not only deepens our comprehension of the cosmos, but also reveals our own connection to it, as the very elements composing our bodies were forged in stellar furnaces. So, when you next gaze upward, appreciate that you are observing not just distant lights, but the grand narratives of cosmic evolution spanning billions of years. At the heart of every star, an incredible process known as nuclear fusion takes place, driven by such extreme conditions that elements themselves are transformed. To truly grasp its significance for the universe, we must delve into the fascinating mechanics of stellar energy. Inside a star's core, temperatures soar to millions of degrees, which, combined with immense pressure, creates an environment where hydrogen atoms can merge into helium, releasing a colossal amount of energy as light and heat. Without this constant outpouring of energy, stars would simply be unable to shine, and the universe would be an entirely different, darker place. If nuclear fusion didn't exist, stars would become cold, inert objects, and life as we understand it on Earth, which relies on stellar light and warmth, would be impossible. Fusion, therefore, acts as the fundamental engine that powers existence, from the growth of plants to our own survival. This energy, born in the star's core, undertakes a long and arduous journey to the surface, migrating through dense layers of gas and plasma over thousands of years. Once this energy finally escapes, it radiates out into the cosmos, lighting up the night sky, and eventually reaching your eyes. You can imagine that every photon of starlight is a messenger from the distant past, a packet of energy that has journeyed across vast stretches of time and space to find you. As a star begins to run out of its primary fuel, its fusion process grows more intricate. Having depleted its hydrogen reserves, it starts to fuse helium into heavier elements like carbon and oxygen. This stage is like a cosmic symphony where each new element adds another layer to the grand composition. But the story becomes even more compelling when the star's fuel is finally gone. The most massive stars conclude their existence in a magnificent detonation called a supernova. This event unleashes tremendous energy and forges even heavier elements, such as iron, in an instant. Far from being just a visual spectacle, this explosion is vital to the universe's evolution, as it disperses these newly created elements throughout space, enriching the interstellar medium with the raw materials for new stars, planets, and perhaps even life. In contrast, smaller stars meet their end in a much less violent manner. They quietly transition into white dwarfs, and while their demise is more subdued, they also play a crucial part in the cosmic life cycle. As these stellar remnants cool and dim, they release the elements they synthesized during their active lifetimes, contributing to the material that will form future generations of stars. Ultimately, nuclear fusion is more than just a stellar engine. It is a process that illuminates our own position within the cosmos. Each of us is built from the very same elements forged in the hearts of these luminous celestial giants. So, when you look up at the starry expanse, remember that you are not just seeing light. you are witnessing the direct result of nuclear fusion that has been occurring for millions of years, a profound reminder of our interconnectedness across all of time and space. This same profound process has inspired scientists to try and replicate it here on Earth, aiming to develop a source of clean and nearly infinite power. If this endeavor is successful, we could be on the verge of a new age of sustainable energy, all powered by the same mechanism that makes the stars shine. Despite our progress, however, nuclear fusion still holds many mysteries, and we have much to learn before we can fully harness its incredible potential. Nuclear fusion is undeniably one of the great marvels of the universe, demonstrating how simple elements can be converted into the energy, light, and warmth that make worlds like ours possible. Within every single star that brightens the night, a story of transformation is unfolding, a narrative of how energy gives rise to life and, in the end, becomes us. The next time you look at the stars, consider the incredible dance of atoms occurring deep within their cores. Stellar systems can be thought of as immense cosmic collections, where each star is a unique piece that shines with its own distinct character. But to understand how these fascinating and diverse arrangements come to be, we must first recognize that stars are not born in isolation. Every star originates within a nebula, a vast cloud of dust and gas drifting through space, where elements like hydrogen and helium mix together to eventually create something extraordinary. Under the right circumstances, cosmic clouds begin to collapse in on themselves, igniting a hot, luminous sphere. It's a truly remarkable thought that the universe, much like a master artisan, blends fundamental elements to bring stars into existence. But what unfolds after a star is born? Much like people, stars progress through a distinct life cycle. They emerge as blazing giants, shining with incredible intensity as they convert hydrogen into helium deep within their cores. You can think of this fusion process as a celestial fire that burns continuously, supplying energy for millions and, in some cases, billions of years. Over vast stretches of time, stars eventually deplete their primary fuel. This brilliant cosmic furnace starts to fade, and the star transitions into the next stage of its existence. Its ultimate fate is determined by its mass. Smaller stars, such as our own Sun, swell into red giants before casting off their outer layers, leaving a dense, hot core that cools into a white dwarf. Conversely, the most massive stars meet a much more dramatic end. They detonate in a supernova, an explosion of such immense power that it can briefly outshine its entire home galaxy. It's truly incredible to consider how a star can conclude its life in such a spectacular fashion. Yet, when stars die, their influence persists, as the leftover nebulae provide the raw material for new stellar nurseries. This cycle of cosmic death and rebirth ensures that the process continues. As they perish, stars enrich the cosmos with essential elements like carbon, oxygen, and nitrogen. It's important for you to realize that, without these stellar contributions, life as we understand it simply could not have emerged. This naturally leads to another fascinating question. How are stars arranged throughout the universe? Just like our solar system, with planets orbiting a central star, the cosmos is filled with stellar systems that can feature multiple stars. These arrangements can be as straightforward as a binary pair locked in a gravitational embrace, or as intricate as massive star clusters containing thousands of stellar siblings. The force of gravity is the master organizer in these cosmic structures, acting like a cosmic choreographer that dictates the position and movement of every star and planet. In crowded stellar environments, these bodies can interact, pulling and pushing on one another in a celestial dance that can result in mergers and the creation of even more elaborate systems. Of course, when we talk about stellar systems, we have to include the planets that call them home. You can find an amazing variety of worlds out there, from rocky planets similar to Earth to colossal gas giants. Some possess thick, crushing atmospheres, others are adorned with brilliant rings, and some even feature entire oceans of molten lava. Each of these worlds holds a unique record of its parent star and its own history. By studying these diverse stellar systems, you and I gain a deeper comprehension of our own position in the universe. Every new discovery, whether it's a distant star or a strange new planet, brings us a little closer to solving the great cosmic puzzle. As you gaze up at the night sky, remember that each twinkling light represents a story of life, death, and renewal, inviting us to keep exploring the boundless mysteries of space. Across the immense stage of the cosmos, planets engage in an elegant ballet that has captivated human curiosity for ages. Have you ever paused to consider the mechanics behind their movements? The dance of the planets is a remarkable display, a celestial choreography governed by the unyielding laws of physics and gravity. An unseen force is responsible for keeping these worlds tethered to their orbital paths. The secret to this cosmic motion lies in the subtle yet powerful force of gravity. Every planet follows its own unique trajectory, with some moving far more rapidly than others, creating a kind of cosmic symphony where each body has a distinct rhythm. Consider our own Earth, perpetually spinning on its axis as it embarks on an endless voyage around the Sun, maintaining a perfect equilibrium between its forward momentum and the Sun's gravitational pull. You can visualize the Sun as a massive weight in the center of a stretched fabric. The planets, like smaller marbles, roll around it in curved paths. The closer a planet is to this central mass, the faster it must travel to resist being pulled in, resulting in a constant interplay of forces where each world must maintain its delicate balance. Without the pervasive influence of gravity, the planets would simply drift aimlessly through the void. Even our closest celestial neighbor, the Moon, plays a part in this intricate gravitational dance. As it circles the Earth, the Moon exerts its own gravitational influence on our planet, most noticeably by creating the rhythmic ebb and flow of our ocean tides. And as you might expect, this is a two-way relationship. The Moon also experiences Earth's pull, which locks it into a unique and stable bond with our world. When you expand your view beyond our own solar system, this planetary dance becomes even more enthralling. Astronomers have discovered entire systems where numerous worlds orbit a single star, presenting a truly stunning spectacle of orbital mechanics. This raises a compelling question about how these diverse worlds are all interconnected in their cosmic ballet. Consider a large family of performers, where every member has a distinct style, but they all move to a single piece of music. The gravitational pull between them can gradually modify their orbits, making it seem as if they are attuning themselves to the music's rhythm. In certain systems, the planets are remarkably different from each other, with some being gas giants and others small rocky worlds. This contrast introduces another dimension to their cosmic dance, where each planetary type performs its own unique steps in its own designated space. How is it possible for a seemingly insubstantial gaseous planet to affect a dense, rocky one? The explanation is found in the force of gravity, which acts like a symphony conductor, compelling every member to stay in time with the beat. Distance is another critical factor in this celestial performance. Planets located farther from their star travel more slowly, as if engaged in a leisurely waltz, whereas those in closer proximity circle rapidly, resembling participants in an energetic celebration. Can you picture residing on a planet where a single orbit around its star takes many decades to complete? For some celestial bodies in our universe, this is their reality. The dance is not solely about gravity, however, as the rotation of planets also contributes to the choreography. Some worlds can spin on their axis in only a matter of hours, while for others, a full rotation requires several days, a factor that can shape their climate, atmosphere, and potential to sustain life. Have you ever wondered about the nature of a day on a planet with a slow rotation, where the sun appears to crawl across the firmament? We should also acknowledge the role of asteroids and comets. These smaller objects can intersect planetary orbits, briefly disrupting their dance and introducing unexpected changes, much like an uninvited guest interrupting a performance. While often viewed as a threat, their presence serves as a reminder that the cosmos is filled with surprises. The arrangement of planets within a system is equally fascinating. In some cases, they form an almost perfect alignment, but in others, their orbits are far more chaotic. The specific configuration is determined by the history of each planetary system, with past collisions and mergers dictating how its various components are structured today. Through our observations of other solar systems, we've learned that this planetary dance is not exclusive to our own corner of the universe. Thousands of exoplanets have been found orbiting distant stars, each with its own tempo and style. If they could communicate, what tales might they share? The quest to find these worlds and chart their orbital patterns represents one of the foremost challenges in contemporary astronomy. Ultimately, the dance of the planets is a tribute to the fundamental nature of our cosmos, teaching us about the elegance of gravity, the variety of celestial objects, and the harmony that can emerge from chaos. Every orbit and every motion reminds us that even though we might feel isolated in this immense universe, we are part of a cosmic ballet that has been in motion for billions of years. So, the next time you gaze upon the starry expanse, remember that you are not merely observing bright specks of light. You are witnessing performers in an unending choreography, each fulfilling its part in the grand spectacle of the cosmos. Within the vast universe we call home, countless enigmas pique our curiosity. And one of the most compelling is the existence of exoplanets, worlds orbiting stars far beyond our solar system that we have yet to visit. How then can we be certain they are real? The credit goes to human ingenuity and the technologies we've engineered to study the most remote stars. For decades, astronomers have scanned the heavens with telescopes built to perceive minuscule fluctuations in starlight. When an exoplanet crosses in front of its star, an event known as a transit, it obstructs a tiny portion of the light. This subtle dimming can be the telltale sign of a faraway world, potentially one with conditions favorable for life. And it was through this method that we first began to grasp that we are not alone. The search for exoplanets has uncovered an incredible diversity of worlds, from gas giants larger than Jupiter, orbiting so close to their stars that their surfaces are hotter than an oven, to small, rocky planets that might be similar to Earth. Each new find prompts us to ask what might exist on these worlds. Could they possess water, the cornerstone of life, or perhaps atmospheres entirely alien to our own? Some of these exoplanets are situated in the habitable zone, the area around a star where temperatures are suitable for liquid water to exist. Just imagine a planet cloaked in oceans, with continents capable of supporting life. The prospect of finding creatures, plants, and entire ecosystems on these remote worlds fires the imagination of both scientists and dreamers. The techniques we employ to find these exoplanets are as varied as the planets themselves. Beyond the transit method, there is the radial velocity technique, which tracks the subtle wobble of a star caused by the gravitational influence of an orbiting planet. This gravitational tug-of-war between the planet and its star is like a cosmic duet where each partner affects the other's movement. Isn't it remarkable to consider that we can confirm the existence of a world thousands of light years away just by observing the gravitational pull it has on its star? Our search has led us to solar systems that defy our expectations, some with multiple exoplanets in complex orbital patterns, and others with strange arrangements like planets on highly elongated paths. This variety compels us to re-examine our understanding of how planetary systems are formed and the evolutionary journeys they have undergone. The intrigue surrounding exoplanets goes far beyond their initial discovery. Analyzing these distant worlds also deepens our comprehension of our own planet, Earth. By comparing the atmospheric makeup of an exoplanet to ours, we can gain new insights into how life originated and developed here. It makes you wonder, could an Earth-like exoplanet one day serve as the destination for future human exploration? This very notion fills us with a sense of anticipation and hope. Yet, the quest for life on distant worlds is far from a simple endeavor, as the sheer scale of space and the daunting distances present immense obstacles. With increasingly sophisticated instruments like the James Webb Space Telescope, we are just starting to peer into the atmospheres of select exoplanets, opening a new window onto these remote systems. By carefully analyzing the light that filters through an exoplanet's atmosphere, scientists can identify the chemical signatures of elements such as oxygen or methane, which could suggest the presence of life. This entire search is fundamentally an effort to resolve one of the most profound questions ever asked by humanity. Are we truly alone in the cosmos? While science fiction has certainly primed our imaginations with tales of space adventures on other worlds, the reality of exoplanets proves to be even more extraordinary. Each new discovery feels like another chapter in an immense, unfolding story, filled with unexpected developments and surprising revelations. As our exploratory capabilities grow, every exoplanet we identify contributes a unique narrative and another chance to grasp the sheer diversity of the universe. Our exploration of space and the continued discovery of exoplanets stand as a powerful testament to human ingenuity. It is through technological advancement and global collaboration that we have managed to look far beyond the confines of our own solar system. Every time an astronomer gazes through a telescope, they embody the spirit of an explorer venturing into the unknown, seeking answers to the universe's countless questions. The search for these worlds doesn't just offer the tantalizing possibility of finding extraterrestrial life. It also encourages us to reflect on our own existence and our unique position within the cosmos. Contemplating the idea that we might belong to a larger interplanetary community within this vast universe is an undeniably thrilling prospect. What secrets might these distant worlds conceal? And what incredible stories are still waiting to be discovered? Our journey of exploration presses on, and it has only just begun. As you continue to look up at the night sky, it's worth remembering that each shining star could be the sun for its own orbiting world. The ongoing search for exoplanets serves as a potent reminder that human curiosity has no limits, and that every new finding brings us a small piece of the answer to our own questions about the universe. This adventure into the unknown is a perpetual one, and space remains a boundless ocean of possibilities awaiting our discovery. Black holes represent one of the most mysterious and enthralling phenomena in the entire universe. But how do they actually come into being? To comprehend this, you must first picture a star of immense mass, a brilliant sphere blazing in the cosmos, creating light and heat through nuclear fusion deep within its core. But what occurs when such a star finally depletes its nuclear fuel? It is at this pivotal point that an incredible transformation is set in motion. At the conclusion of its life cycle, a massive star undergoes a colossal explosion referred to as a supernova. This event is more than just a spectacular flash of light and energy. It is the crucial turning point that can ultimately give rise to a black hole. In the midst of a supernova, the star's outer layers are violently expelled into space, leaving behind an incredibly dense remnant core. So, why does this stellar core have the potential to become a black hole? The answer lies in the overwhelming force of gravity. For a collapsed stellar core of sufficient mass, the gravitational pull is so extreme that it begins to draw in all surrounding matter. Eventually, this gravitational force can intensify to the point where nothing, not even light itself, is able to escape its grasp. This is the birth of a black hole, a region in space-time where gravity becomes an inescapable trap for anything that ventures too close. Doesn't it seem astonishing to consider that there are locations in our universe from which light itself cannot break free? But what actually exists inside a black hole? This is a question to which science still lacks a definitive answer. It is theorized that at its center lies a singularity, a point where the known laws of physics completely break down. Try to imagine a place where space and time operate in ways that are entirely alien to our everyday experience. That is the singularity at the heart of a black hole. Encircling this singularity is the event horizon, the boundary that marks the ultimate point of no return. Once you cross this threshold, escape becomes impossible. But what would it feel like to pass through the event horizon? What would that experience be? As you neared this boundary, you would feel gravity intensify in an extreme and uneven way, a phenomenon known as spaghettification. Can you picture your body being simultaneously stretched and compressed, deforming as you get closer? In this way, black holes are not just cosmic mysteries, but also phenomena that fundamentally challenge our perception of reality. Black holes also perform a vital function in the evolution of galaxies. It is widely believed that supermassive black holes reside at the centers of most galaxies, where they act like cosmic engines that heavily influence the formation and development of everything around them. Have you ever wondered what it might be like to inhabit a galaxy with a central black hole? Its immense gravitational influence can shape the orbits of stars and planets, fostering a dynamic and truly captivating cosmic environment. Moreover, black holes are not static objects. They can expand by consuming matter from their immediate vicinity, swallowing entire stars, gas clouds, and cosmic dust. This feeding process generates a brilliant emission known as accretion radiation, which can be seen from vast distances. In fact, some of the most active black holes are so voracious that they launch powerful jets of particles at velocities approaching the speed of light, giving us valuable clues about the nature of these enigmatic objects. The very existence of black holes has spurred fascinating theories regarding the fundamental structure of space-time itself. Certain hypotheses propose that they might function as gateways to other universes or dimensions. Could you imagine a journey through a black hole that transports you to a completely different reality? While this idea has long been a staple of science fiction, science is actively investigating these possibilities, and each new discovery moves us closer to solving the deepest mysteries of the cosmos. The investigation of black holes has been a significant catalyst for progress in the field of theoretical physics. Among the most formidable challenges facing physicists today is the development of a unified theory that can reconcile general relativity with quantum mechanics. Black holes exist precisely at the convergence of these two theories, forcing us to confront profound questions regarding the fundamental nature of space, time, and existence itself. It makes you wonder if we can ever truly grasp their inner workings. Thanks to recent breakthroughs in technology, we have finally reached a point where direct observation of black holes is possible. The first ever image of a black hole, produced by the Event Horizon Telescope collaboration, represents a pivotal moment in the history of astronomy. This picture, which captured the silhouette of the black hole at the core of the M87 galaxy, was a monumental leap forward in our comprehension of these celestial behemoths, leaving us to anticipate what other secrets they might unveil. The study of black holes encourages us not only to better comprehend the universe, but also to contemplate our own significance within it. When faced with such an immense and enigmatic cosmos, it is natural to question our place in the grand scheme of things. The reality of these cosmic titans serves as a powerful reminder that an incredible amount remains for us to explore and understand, prompting you to ask what other enigmas the universe has in store. Ultimately, black holes stand as a testament to the magnificence and intricacy of the cosmos. They compel you to peer beyond the familiar and challenge the very foundations of what you accept as truth. As our exploration of the universe persists, black holes will undoubtedly continue to be a source of deep fascination, symbolizing the cutting edge of scientific inquiry and beckoning us to never stop searching for answers. Who can say what breakthroughs lie ahead, as each new insight could unlock a more profound grasp of reality and our role within it. Within the vast expanse of the cosmic ocean, where every star acts as a beacon in the darkness, you encounter the captivating structures known as galaxies. What exactly are these formations, and what makes them so vital to our understanding of the universe? These immense collections of stars, gas, dust, and dark matter function like celestial islands, each possessing a unique structure and personality. Some are majestic spirals, resembling swirling vortexes of light, while others appear as elliptical galaxies with softer, more rounded forms. And some are even irregular, seemingly sculpted by cosmic chaos. Let's imagine galaxies as sprawling cosmic cities. How would you picture their layout? At the heart of many galaxies, our own Milky Way included, resides a supermassive black hole, a sort of gravitational titan that governs everything in its vicinity. Picture a bustling central square toward which everything gravitates, with stars orbiting like the inhabitants of this metropolis, all following gravitational paths that ensure cosmic order and equilibrium in a celestial dance essential for the galaxy's stability. As you gaze up at the night sky, it is hard not to feel insignificant when contemplating the sheer vastness of the universe. This perspective gives rise to a compelling question. Just how many galaxies exist? Current astronomical estimates suggest that the observable universe may contain over 2 trillion galaxies. That represents trillions of stellar collections and potential worlds awaiting exploration. Each of these galaxies acts as a cosmic laboratory, where the fundamental processes that govern matter and energy unfold. Every galaxy tells its own unique story, one that has been unfolding over billions of years. Their formation begins with minor fluctuations in the early universe's gravitational field, which gradually pull in gas and dust. With the passage of eons, these vast clouds of matter condense to ignite stars. This makes each galaxy a complex ecosystem where stars are born, live out their lives, and die, with their remains providing the raw material for new stellar generations in a perpetual cycle of cosmic life and death. Galaxies are also the settings for some of the most spectacular events in the cosmos. Have you ever tried to visualize what happens when 2 galaxies collide? These interactions can be astonishingly dramatic, like a cosmic ballet that reshapes everything involved. When galaxies intersect, their powerful gravitational forces can warp their structures, eject stars from their orbits, and sometimes result in a merger that creates an entirely new, larger galaxy. This process unfolds over billions of years, but it triggers intense bursts of star formation. Let's delve into the diversity you find among galaxies. Did you know they can be categorized into distinct types? As mentioned, spiral galaxies feature arms that sweep out from a central bulge, whereas elliptical galaxies are more uniform in appearance and lack these prominent features. This classification system is a valuable tool for understanding how galaxies form and evolve over time. Irregular galaxies, on the other hand, are cosmic puzzles, often created by gravitational disruptions and collisions, and their chaotic forms offer clues into the universe's history. Every ray of light from a galaxy carries with it stories from its distant past. When you observe a faraway galaxy, you are effectively looking back in time, sometimes by billions of years. By carefully analyzing the light they send across the cosmos, astronomers can deduce the chemical makeup of their stars, detect the presence of gas and dust, and monitor the activity around their central black holes. Each color and flicker is a piece of evidence revealing that galaxy's evolutionary journey. However, a significant part of the galactic equation remains unseen. Dark matter, a mysterious substance that does not emit or interact with light, is a critical component of a galaxy's structure. Although you cannot observe it directly, its gravitational influence is unmistakable. Without it, galaxies would lack the cohesion needed for their stability. It acts as an invisible framework that holds the entire cosmic structure together, much like the hidden supports of a massive building. The age-old question of whether we are alone in the universe is intrinsically tied to the study of galaxies. With billions of stars in every galaxy, many of which host their own planetary systems, the potential for other habitable worlds is simply staggering. It leads you to wonder just how many other civilizations might be out there, observing their own galaxies. This thought inspires reflection on our place in the cosmos and fuels the continuing quest for life beyond our home planet. With every advance in telescope technology, our comprehension of galaxies deepens and broadens, allowing us to probe regions of the universe once entirely out of view. Each new observation raises more questions, pushing the boundaries of how we perceive the cosmos. We find ourselves exploring not just the vastness of space, but the very nature of time, our origins, and the destiny of everything we know. So what unfolds when two colossal collections of stars encounter one another within the infinite expanse of the universe? A galactic collision ranks among the most breathtaking events imaginable, a celestial dance that reshapes the very structure and fate of these immense stellar systems. But to truly understand its consequences, you must first appreciate how this cosmic ballet plays out. When you picture galaxies, you might envision immense, shining spirals or ellipses suspended in the void. But it's crucial to remember that these giants are rarely isolated. The universe is populated by billions of galaxies, each containing its own stars, planets, and secrets. It is through their interactions, mergers, and even collisions that some of the most stunning cosmic transformations are created. Occasionally, these galaxies drift into proximity, where the inexorable pull of gravity initiates an interaction between them. Much like the attraction between two powerful magnets, they can exert an overwhelming force on one another, setting the stage for a truly spectacular event. It's important for you to realize, however, that these collisions bear no resemblance to a terrestrial car crash. Despite appearing densely packed with stars, galaxies are overwhelmingly composed of empty space. Consequently, when two galaxies collide, the chances of individual stars actually hitting one another are exceptionally low. What truly occurs is a profound gravitational distortion of the galaxies themselves. Their familiar shapes are twisted and warped as countless stars are rerouted onto entirely new trajectories, like partners in a cosmic waltz that takes millions of years to complete. During this intricate gravitational dance, stars can be drawn closely together, often triggering massive waves of new star formation in regions where gas and dust become highly concentrated. This process can be incredibly dramatic. A galactic collision can cause the rate of star birth to surge, as if the galaxies are setting off cosmic fireworks. Brilliant bursts of newly formed stars can light up the surrounding space, creating a visual marvel for astronomers to witness. However, this celestial choreography is not without its chaos. As galaxies merge, some star systems may be violently ejected from their original homes, hurled like projectiles into the vast emptiness of intergalactic space. Such events can deeply destabilize the stellar populations and permanently alter the evolutionary path of the galaxies involved, making each collision a process that shapes the destiny of billions of stars. These galactic encounters are far from rare occurrences in the cosmos. In fact, our own Milky Way galaxy is currently on a collision course with its neighbor, the Andromeda Galaxy. In roughly 4 billion years, these two massive star systems will begin to merge, an event that will profoundly transform the night sky for any observer looking up from Earth, creating new constellations and altering our cosmic landscape forever. Interactions between galaxies also fuel other extraordinary phenomena, such as the formation of vast galaxy clusters. These are colossal assemblies containing hundreds or even thousands of galaxies bound together by gravity, like a cosmic metropolis where each new encounter can spark further interactions. Furthermore, these mergers can significantly impact the supermassive black holes located at the hearts of galaxies, as their cores combine to create even more monstrous central black holes. Remarkably, these cosmic collisions can also serve as catalysts for creation. Within the rich mixture of elements and immense energy unleashed during these events, the ideal conditions for forming new planets and perhaps eventually life can emerge. In this way, You can view a galactic collision not just as a transformative event in space, but as a cosmic dance that has the potential to give rise to something entirely new and beautiful. While scientific understanding of these phenomena has advanced tremendously, there remains so much more for us to learn. Each observed galactic collision offers a precious opportunity to study how the universe's structures are built and how matter and energy are woven together in this grand celestial ballet. The ongoing observations bring us progressively closer to solving the profound mysteries hidden throughout the cosmos. The awe inspired by galactic collisions serves as a powerful reminder that, despite the unimaginable scale of the universe, everything is interconnected. The same fundamental forces that shape the destiny of galaxies also influence our own existence. Every star you see in the night sky is a participant in this magnificent narrative, a story that continues to unfold across the immense canvas of space and time. The next time you gaze at the night sky, consider that you are observing more than just stars. You are seeing the outcome of a cosmic ballet that began with time itself. Among the universe's most profound enigmas is dark matter. Despite being undetectable by sight or touch, its existence is certain. To grasp how something so imperceptible can shape everything we know, picture yourself in a boundless ocean. While you might only see water, unseen currents below are directing the flow, and dark matter operates in much the same way, an invisible yet foundational force. Researchers have determined that dark matter constitutes roughly 25% of the cosmos, yet its true nature remains a puzzle. It doesn't emit light or any form of radiation, unlike the atomic matter that builds stars, planets, and even you. This makes it an omnipresent yet invisible shadow cast across space. So, how can we be sure it is there? The most compelling evidence emerges from observing the motion of galaxies, which holds one of the most exciting clues to its existence. Astronomical observations reveal that stars on the outer rims of galaxies orbit at incredible velocities. Based on the gravity generated by visible matter alone, these stars should be flung into intergalactic space, but they are not. This discrepancy strongly implies the existence of an unseen mass exerting a powerful gravitational pull, and this is precisely the role attributed to dark matter. It is akin to feeling a gentle nudge from an unseen person at a crowded gathering. You cannot see them, but their effect is undeniable. This invisible force is what binds galaxies together, and without it, our model of the cosmos would completely fall apart. Dark matter's influence extends far beyond the rotation of individual galaxies. It is the primary architect of the universe's large-scale structure. You can visualize this by imagining a vast cosmic fishing net, where the filaments of dark matter act as the ropes. These invisible threads connect everything, drawing galaxies together into enormous clusters and superclusters. Without this underlying scaffolding, the universe would lack the magnificent, organized structure we observe today. The enigmatic character of dark matter has spurred scientists to create numerous theories and models in an attempt to explain it. A leading hypothesis proposes that it is composed of exotic particles that have so far eluded detection. Think of it as a grand cosmic puzzle with many missing pieces. Each new finding about dark matter provides another piece, gradually bringing the complete image of our universe into clearer focus. Even with our most advanced efforts, dark matter continues to be exceptionally elusive. We have constructed massive detectors deep underground and launched sophisticated observatories into orbit, all dedicated to finding this enigmatic particle. To date, however, it has managed to escape our grasp, much like trying to catch smoke with your hands. You can sense its presence, but it offers nothing to hold on to. You might wonder why deciphering the nature of dark matter is so critical. The reason is straightforward. Our entire cosmic narrative is incomplete without it. The existence of dark matter governed the formation and evolution of galaxies from the very beginning. In fact, every star, planet, and living being on Earth owes its existence to the fundamental interplay between this invisible substance and the matter we can see, serving as a profound reminder of the vast, unseen universe. As the scientific investigation progresses, every breakthrough concerning dark matter seems to unlock even more profound questions. It makes you wonder if other, undiscovered forms of matter exist, and what part they might play in cosmic evolution. This ongoing quest for answers is thrilling, tapping directly into the fundamental human drive to comprehend our own place within the vastness of space. Ultimately, dark matter compels you to contemplate the very definition of reality itself, especially when faced with phenomena that exist beyond our senses. It is a challenge to look past the visible world and recognize the cosmos as a realm teeming with secrets yet to be revealed. This invisible substance, with its undeniable influence, acts as the thread that stitches the universal fabric together, providing it with both form and substance. As our cosmic exploration continues, the journey to uncover the universe's mysteries has only just begun. It may surprise you to learn that the universe possesses a remarkably organized architecture, resembling an immense web. This cosmic web stretches across trillions of light years, linking galaxies, galaxy clusters, and the very filaments of dark matter we have been discussing. The fascinating questions are how this complex network came to be, and what its existence signifies for us. Picture a colossal three-dimensional map where galaxies are not sprinkled about randomly, but are arranged in distinct patterns that trace the entire history of the cosmos. This arrangement is far more than a simple curiosity. It holds the secrets to the universe's origin and evolution. Scientists have observed that this galactic distribution is highly uneven, with some areas crowded with galaxies while others are vast, empty voids, which raises the question of what caused this specific structure to form. In the immediate aftermath of the Big Bang, the universe existed as a searingly hot plasma of subatomic particles. As this primordial soup expanded and cooled, minuscule variations in its density began to seed the growth of future structures. Regions that were infinitesimally denser began to gravitationally attract more matter, amplifying these dense areas and giving rise to the first filaments of the cosmic web. You can think of it like a crowded party, where a small cluster of people naturally draws in others, making the group larger and denser over time. Galaxies tend to congregate in groups and superclusters along cosmic filaments, which causes the emptier areas to become immense voids in space. But what if I were to suggest that these voids hold their own significance? In fact, they are crucial for piecing together the universe's history and tracing the path of its evolution over eons. Now, let's consider the function of dark matter in this grand design. While it remains invisible to us, its presence is undeniable, serving as a cosmic adhesive that binds galaxies. If this dark matter didn't exist, galaxies would simply drift apart, making their initial formation and continued stability impossible. But the question remains, what exactly is dark matter? This enigma has captivated scientists for decades, and though it is thought to constitute around 85% of all matter in the cosmos, its fundamental composition is still unknown. Through meticulous observation, we have successfully charted the distribution of dark matter throughout space. Picture yourself viewing the night sky with a powerful telescope. You can see the stars and galaxies, but what remains hidden is the intricate web of dark matter that envelops them. This network functions as a sort of cosmic scaffolding, providing the underlying structure that dictates how the universe is shaped and where new celestial objects will form. Have you ever considered the deep connection between this cosmic web and the development of galaxies? As galaxies journey along these filaments of dark matter, they often collide and merge, giving rise to even larger galactic structures. This process of merging not only reshapes the galaxies involved, but also ignites bursts of new star formation, fueling a perpetual cycle of stellar life. The cosmic web serves as more than just a map of density. It is a chronicle of the universe's entire past. It allows us to comprehend how matter has been arranged across space, and the profound influence this arrangement has had on the evolution of large-scale cosmic structures. With every new finding, astronomers move one step closer to solving the deepest mysteries of the cosmos. Imagine if you could actually navigate through this incredible network. Each galaxy, every cluster, and each void would represent a stop on a spectacular voyage filled with awe and discovery. From the violent explosions of stars during galactic collisions to the quiet birth of new worlds, the cosmic web stands as a testament to the universe's intricate beauty and complexity. As we probe deeper into this cosmic labyrinth, fundamental questions about our own existence begin to emerge. If we are just a tiny fragment of this unimaginably vast web, what does that imply for us as a species? What is our impact on this immense reality, and in turn, how does it shape us? The quest for these answers compels us to contemplate our unique part in the cosmic narrative. While we continue our exploration of this captivating maze, each new piece of information serves as a powerful reminder that the universe is a dynamic, ever-evolving place. The cosmic web isn't merely a static arrangement of galaxies and dark matter. It is a profound symbol of the interconnectedness that permeates all of existence. Every star, every planet, and every living thing is intricately woven into this grand design. And while we might sometimes feel isolated in the vastness, we are truly part of something much larger than ourselves. So, the next time you gaze up at the night sky, remember that you are witnessing more than just distant stars. You are observing the cosmic web in real time, a colossal system that required billions of years to take shape and is still evolving right before your eyes. The universe is an astonishing place, teeming with mysteries and marvels that are still waiting to be uncovered. What are star clusters, and what makes them so compelling? These celestial groupings provide us with a special window into the chronicle of the universe. Think of a sprawling garden where the stars are like flowers, each possessing its own unique color and brightness, yet all rooted in the same cosmic soil. This is an apt description for star clusters, which are bound by gravity and travel through the cosmos as a single entity. Clusters are generally classified into two primary types: globular clusters and open clusters. Globular clusters are like ancient, densely populated cities, packed with old stars that have journeyed together for billions of years. In contrast, open clusters are more like vibrant gatherings of young companions, brimming with energy, and recently formed stars. A single globular cluster can harbor hundreds of thousands of stars, whereas an open cluster might contain just a few dozen or a few hundred, each telling its own distinct story. How do these stellar collections come into being? Deep within a nebula, where vast clouds of gas and dust gather, gravitational forces begin to draw the material inward. As this matter compresses and its temperature soars, new stars are ignited. Over time, these newborn stars coalesce into groups, forming clusters that embark on their own voyages through space. Each cluster, with its unique stellar population, offers a snapshot of cosmic evolution, a history written in light and time. To astronomers, star clusters are of immense importance, as studying them is akin to reading a detailed book on the history of the cosmos. By analyzing the behavior of stars within these groups, scientists can gain profound insights into how stars are born, how they mature, and how they evolve over billions of years. Can you envision witnessing the entire life cycle of a star, its birth, its growth, and its eventual demise, all within a single location? This is precisely the opportunity that star clusters provide. In globular clusters, the stars are exceptionally old, with some exceeding 13 billion years in age. This makes them living relics from an era when the universe was fundamentally different from what we see today. By examining these ancient stars, scientists can develop a clearer picture of the conditions in the early universe. It is truly remarkable to consider that some of these celestial bodies have existed nearly since the dawn of time itself. Conversely, open clusters present an entirely different view. These groups are typically populated by brilliant young stars that are still in their formative stages, making them hubs of stellar activity. Within them, new stars are constantly being born, even as others are starting to die. A continuous cycle of creation and destruction that reminds us the universe is in a state of perpetual transformation. The gravitational interplay between stars within a cluster is also a source of fascination, as their close proximity means they continually influence one another throughout their shared journey. Certain stars can approach each other so nearly that their gravitational pull results in a merger, forging a star that is even more massive and luminous. It's remarkable to consider how profoundly stars can affect one another, but their influence doesn't stop there. These clusters also function as ideal natural laboratories for investigating dark matter. This enigmatic substance, which remains invisible to us but whose presence is confirmed by its gravitational effects, is instrumental in the formation and stability of star clusters. By examining the behavior of dark matter in these formations, we can achieve a deeper comprehension of the universe's overall structure. Some stellar clusters are so incredibly dense that the space between stars is a theater of perpetual interaction. Within these crowded environments, stars are continuously tugged by the gravity of their neighbors, generating a dynamic and ever-shifting celestial landscape. You can envision it as a cosmic ballet, where every star performs a specific part in a grand, universal choreography. Furthermore, these clusters are also the very places where many of the universe's heaviest elements are forged. When massive stars perish in supernova explosions, they unleash immense energy and a wealth of elements that are then recycled into new stars and planets, making you wonder at the fact that elements within your own body may have originated in the core of a faraway star. Far from being mere cosmic spectacles, Star clusters are of fundamental importance to our understanding of the universe's history and destiny. Analyzing their composition, dynamics, and evolution provides us with answers to core questions about how our cosmos came to be and what its future holds. So, the next time you gaze up at the night sky, consider that each point of light could be part of a vast stellar family, holding within it the secrets of the cosmos. They are an open invitation to explore, to contemplate cosmic life and death, and to imagine what other discoveries await us in the immense garden of the universe, where each cluster is a single thread in a tapestry of interwoven narratives, waiting to be read. But what is the function of dust on the vast cosmic stage? While it is frequently disregarded, cosmic dust is a quiet but essential actor in the universal narrative. Picture a great expanse of gas and particles, in which every single grain of dust serves as a minute building block for the construction of stars and worlds. This dust, drifting through the cosmos, might appear inconsequential, yet its impact is tremendous. It originates from the cataclysmic explosions of supernovae and from the fusion of elements deep inside stars. When a star dies, it ejects enormous quantities of matter that scatter into space, eventually cooling and coalescing into tiny dust particles, each one a historical fragment of the universe, enriched with elements once forged inside a brilliant star. So, how does this dust specifically contribute to the formation of new stars and planets? The solution is found in its capacity to attract and fuse with other materials. Within nebulae, which are immense clouds of gas and dust, these particles serve as the initial seeds for future suns. As more dust and gas gather, gravity takes over, compelling smaller particles into larger aggregates until the conditions at the heart of the nebula are perfect for a new star to ignite. However, some of this dust follows a different path, becoming the fundamental material for planets. Much like a painter choosing pigments, the universe selects specific elements from this cosmic dust to create new worlds, making planets not just celestial objects, but living histories of the very dust that formed them. Did you know that cosmic dust is also a key player in the emergence of life itself? The elements that constitute this dust, like carbon, oxygen, and nitrogen, are the cornerstones of life as we understand it. As planets coalesce from this material, they inherit these essential life-giving ingredients, meaning that dust doesn't just build stars and planets. It also prepares the ground for potential life. This dust acts as a conduit between the universe's past and its future, becoming the very stage upon which life's story can unfold. It is truly captivating to realize that every atom in your body and every molecule of water you drink can be traced back to this primordial stardust. Cosmic dust's role extends beyond just creation. It also shapes the dynamics of the cosmos. Its particles can obstruct the light from distant stars, which creates dark patches in space that, paradoxically, enable us to study the universe in new ways. This effect is similar to how a passing cloud can block the sun, revealing details that were previously hidden in the glare. Can you even begin to guess how many cosmic wonders lie concealed behind these veils of dust? For astronomers, decoding the secrets held within these tiny particles has become a significant endeavor, pursued with advanced telescopes and space probes. As our technology improves, we uncover more detail about this material, including the discovery of complex molecules that are the very building blocks of life. This revelation suggests the incredible possibility that cosmic dust not only helped form our solar system, but may have been instrumental in seeding life elsewhere in the cosmos. This same cosmic dust is abundant right here in our own galaxy, the Milky Way. Within its majestic spiral arms lie enormous, invisible clouds of dust that exert a powerful influence over the birth of new stars. This unseen celestial process is absolutely essential for the ongoing evolution of our galaxy. Without it, the stellar life cycle would halt, and the universe would look entirely different. Ultimately, the study of cosmic dust provides a unique lens through which we can view the distant past of the universe itself. By examining the makeup of this dust across various cosmic regions, scientists can deduce how the universe has evolved over millennia. Every speck of dust serves as a miniature fossil, chronicling the tale of its own creation, its voyage through time, and its impact on the subsequent generations of stars and planets. So the next time your gaze falls upon the night sky, consider that each star, planet, and glimmer of light you observe is profoundly linked to this cosmic dust, a seemingly minor component whose role is absolutely essential to the grand story of the universe. When you next contemplate the cosmos, I hope you'll remember the unassuming dust that quietly constructs and animates the universe's marvels. Who can say what other secrets these cosmic particles conceal, awaiting discovery by those who venture to see beyond the surface? This brings us to a captivating exploration of the rings of Saturn, one of the most brilliant spectacles in our solar system. Have you ever stared at the heavens and pondered what lies just beyond the familiar stars? Saturn, our solar system's second-largest planet, captivates us not just with its immense scale, but also with its magnificent system of rings. But what are these rings, precisely? What process brought them into being, and what makes them so extraordinary? Saturn's rings appear like an expansive necklace of celestial gems, shimmering with hues and textures that defy our imagination. Composed primarily of ice and rock fragments, these rings span more than 200,000 kilometers. What's truly baffling is that, despite this enormous width, their thickness measures only a few hundred meters. How can that be? Picture a colossal, paper-thin pizza where every single topping and sliver of ice is vital to the whole. So, what is the force behind such mesmerizing beauty? The explanation is rooted in gravity. Saturn's tremendous mass makes it act like a cosmic magnet, drawing in the icy and rocky debris that now orbits around it. The planet's gravitational pull not only holds the rings in place, but also animates them. At times, the influence of a small passing moon can send ripples through the ring material, generating stunning patterns and waves, a celestial dance of shimmering particles choreographed by the laws of physics. Let's delve a little deeper into what these rings are made of. While they may appear as a brilliant white, they are actually composed of many different forms of ice, and you might be surprised to learn that some of these frozen chunks can be as large as mountains. Interspersed with this ice are minuscule particles of dust and rock, which combine to produce a singular visual phenomenon. It's as if nature has used the cosmos as a vast canvas, painting a masterpiece with its own unique palette. As our understanding of the rings grows, it's fascinating to consider where they came from. The prevailing theory posits that they are the remnants of a moon that drifted too close to Saturn. The planet's gravitational force was so overwhelming that it ripped the moon to shreds, transforming it into the countless pieces that now constitute this breathtaking ring system. It's quite remarkable how an event of such catastrophic proportions could result in something so exquisitely beautiful. However, The allure of Saturn's rings extends beyond their visual appeal. They are also crucial for piecing together the history of our solar system. Through studying the rings, scientists can uncover valuable clues about how planets and their moons were formed. Every particle that circles Saturn carries a narrative, a story that stretches back billions of years. Just think of the hidden knowledge they might one day unveil. The rings themselves are far from static. They are in a state of perpetual motion and transformation. Some particles may collide, forging entirely new structures and patterns within the rings. Other fragments might get pulled away by Saturn's gravity or its moons, causing the overall shape and dimensions of the rings to evolve over time. It's a sobering thought that Saturn's rings could completely vanish within the next 100 million years. A powerful reminder that nothing in the immense cosmos lasts forever. Speaking of moons, the interplay between Saturn and its satellites profoundly shapes the structure of the rings. Certain moons function as cosmic shepherds, helping to confine the ring material and maintain its form. For instance, the moon Prometheus has a pivotal role in sculpting the edges of the rings, which gives rise to features known as gravitational loops. It's as though these moons are celestial gardeners, meticulously tending to their spectacular ring garden. When we observe the rings more closely, we find they are not all alike. Saturn possesses multiple distinct rings, each with its own unique properties. The most well-known is the A ring, which is the brightest and most densely packed. Yet there are others, like the F ring, that are considerably more slender and difficult to perceive. The reason for these variations lies in the quantity and size of the particles that constitute each individual ring. Sunlight is also a key player in the magnificent display of the rings. As light from the sun strikes them, the countless ice particles reflect it in a way that produces a stunning spectrum of colors and brilliance. The rings can appear almost transparent or shine with intense brightness, all depending on the sun's position and the angle from which you view them. It's truly incredible to realize that the light you see has traveled millions of kilometers just to illuminate these celestial wonders. In the end, Saturn's rings are far more than just a breathtaking celestial feature. They serve as a testament to the history of our solar system, beautifully reflecting the interplay of cosmic forces and the elegance of nature. Every single fragment within these rings holds its own history, a narrative deeply connected to the greater mystery of the universe. What else might we uncover about these rings? And what can they teach us about our own position in the cosmos? So the next time you cast your eyes to the sky and spot Saturn, try to remember that its rings are much more than a lovely picture. They stand as a profound symbol of the universe's complexity and splendor, a universe that perpetually awaits our exploration and understanding. Human curiosity has always driven research and discovery, and those who continue to look up will surely keep unraveling its secrets. Are you prepared to continue the journey? The notion that our universe is expanding is among the most captivating and mind-bending ideas in all of modern cosmology. To truly grasp what this means, picture yourself slowly inflating a balloon. As you blow into it, the surface stretches, and every single point on that surface moves farther away from all the others. Our universe behaves in a similar fashion, constantly growing larger, a reality we've come to understand through a series of incredible scientific breakthroughs. The initial evidence for this cosmic expansion was uncovered by the astronomer Edwin Hubble during the 20th century. He made the pivotal observation that distant galaxies are all receding from us, and their speed increases with their distance. It's a truly stunning realization that space itself is stretching, carrying entire galaxies along for the ride. This discovery naturally led to a profound question. If everything is expanding, what did it expand from? The path to answering this question brings us to the renowned Big Bang. Contrary to its name, the Big Bang wasn't an explosion within space, but was instead the very expansion of space itself from an infinitesimal point. In its earliest moments, the universe existed in a state of extreme heat and density. From that initial instant, it has been perpetually expanding and cooling, a process that gave rise to the formation of particles, then atoms, and ultimately the vast star systems and galaxies that you can observe today. This expansion, however, presents a direct challenge to our conventional understanding of gravity. While gravity typically acts as a cosmic adhesive, binding objects together, on the grandest scales it competes with a formidable adversary: dark energy. This enigmatic force seems to be the driver behind the accelerating expansion of the cosmos, pushing galaxies apart ever faster. The idea that some unseen influence is actively working against gravity forces us to reconsider the fundamental nature of reality itself. Contemplating this perpetual expansion inevitably leads you to ponder the ultimate destiny of everything that exists. If the universe is set to expand forever, what does its distant future hold? Many scientists theorize a future in which galaxies will drift so far from one another that the night sky will eventually go dark. In this scenario of infinite expansion, all the stars will eventually exhaust their fuel, and the cosmos will descend into a cold, desolate, and profoundly lonely state. Even so, the universe's expansion isn't merely some remote, abstract concept. It has tangible relevance to our existence. For instance, the phenomenon of redshift, observed in the light from faraway galaxies, is a key tool for deciphering how the universe operates. As a galaxy moves away from you, the light it emits is stretched, shifting its wavelength toward the red end of the spectrum. This effect allows us to measure the recession speed of galaxies and deepen our comprehension of the universe's structure. Furthermore, the investigation into cosmic expansion has spurred the development of technologies and instruments that influence our daily lives. The advanced telescopes and scientific equipment we rely on today are founded on physical principles first uncovered through the study of the cosmos. This quest to understand the universe also encourages you to reflect on your own place within this immense, unfolding story. When you gaze at the stars, you are not only looking into the distant past, but also catching a glimpse of a universe in constant transformation. Yet the expansion of the universe is far from the only enigma we face, as questions about the very fabric of time and space run deeper than we can currently fathom. Imagine if time isn't a straight line but can instead bend and distort in ways we have yet to grasp. In this vast cosmic arena, it is human curiosity that serves as our primary guide. This innate drive for knowledge compels us to look upward and question our position in the grand scheme of things, igniting the very spirit of scientific exploration. As we persist in our observations and studies, it's crucial for you to recognize that acquiring knowledge is an unending journey. Every new discovery simply paves the way for new questions, beckoning us to venture deeper into the unknown. So, the next time you find yourself looking at the night sky, consider the magnificent expansion of the universe and all the wonders that still await discovery. This cosmic growth is an invitation to meditate on our existence and purpose within a perpetually evolving reality, reminding us that we are part of something immeasurably vast. In this profound search for cosmic understanding, every one of us assumes the role of an explorer. What new frontiers, then, lie ahead in our future? What cosmic secrets will be unveiled by the next generation of scientists and visionaries? The journey to find these answers is only just beginning, and they might be far closer than you think. Now, let's explore a phenomenon that sounds like it was pulled from science fiction, but is, in fact, one of our most powerful tools for observing the cosmos: gravitational waves. To understand them, you can visualize space-time as an immense, flexible fabric that contains everything in our universe. When an object with tremendous mass, like a star or a black hole, moves through this fabric, it generates ripples, similar to the way a stone creates waves when tossed into a pond. These ripples are gravitational waves, the faint echoes of cataclysmic events that occurred in the most distant reaches of space. Astronomers have identified that the most potent sources of these waves are events like supernova explosions, the merging of neutron stars, and especially the collision of two black holes. When a pair of black holes spiral toward each other and ultimately combine, they unleash a staggering amount of energy, far exceeding the output of billions of suns combined. It is the signature of such monumental occurrences that gravitational waves carry across the universe, providing us with an entirely new way to perceive the cosmos. This allows you to listen to the universe's most dramatic events, not just see them. This powerful discharge of energy radiates across the cosmos in the form of waves, which are perceptible here on our own planet. Our confidence in their existence comes from a landmark event in 2015, when researchers at the Laser Interferometer Gravitational Wave Observatory, or LIGO, confirmed their first direct detection. This historic achievement validated a prediction Albert Einstein had made over 100 years prior in his theory of general relativity, igniting palpable excitement throughout the scientific world, as it signified a completely new way of observing the universe. Capturing evidence of gravitational waves is a task of extraordinary difficulty. Instruments such as LIGO possess such incredible sensitivity that they can measure shifts in distance that are smaller than the diameter of a single proton. To give you some perspective, this level of precision is comparable to measuring the width of a strand of hair from several kilometers away. As a gravitational wave moves through Earth, it subtly stretches and compresses space itself, and it is these minute distortions that the detectors are built to record. So, what knowledge do these cosmic ripples actually carry? Every detected event provides a unique narrative about the universe's workings. For instance, analyzing the waves generated by the collision of two black holes allows scientists to deduce their respective masses and how far away the cataclysmic event occurred. This information not only deepens your understanding of the behavior of these enigmatic objects, but also offers vital clues about their formation and life cycle throughout cosmic history. This new field of study is fundamentally reshaping the science of astronomy. For centuries, our view of the universe has been almost exclusively through the medium of light. Gravitational waves, however, grant us the ability to effectively listen to the cosmos. You can think of the universe as having a distinct acoustic language, with these waves representing its deepest, most profound sounds. With each signal we intercept, we are essentially deciphering another note in this grand cosmic symphony. The immense significance of this breakthrough lies in its power to let us witness cosmic events that would otherwise remain completely hidden from view. Take, for example, a supernova explosion. It can be challenging to observe through conventional telescopes depending on the light spectrum, yet its gravitational waves can be detected irrespective of their origin. This capability dramatically broadens your comprehension of the universe and opens up unprecedented avenues for discovering phenomena we never knew existed. Furthermore, the study of gravitational waves prompts fascinating new inquiries into the fundamental structure of the cosmos itself. It pushes you to ask if there are colossal objects out in space that we simply cannot see. These waves may become a critical tool in identifying dark matter and other mysterious components of the universe that remain beyond our current grasp. Each new detection is like turning the page in an unfinished cosmic manuscript, with every discovery raising even more profound questions for us to explore. As our technology continues to evolve, the precision of these detectors will inevitably increase, which means we will soon be able to capture gravitational waves from events that are even more ancient and remote. Imagine the possibility of hearing the residual echo from the creation of the universe itself, a moment that transpired more than 13 billion years ago. The potential for discovery is as boundless as it is thrilling. This quest for gravitational waves has also become a powerful catalyst for international scientific partnership. Researchers across the globe collaborate within a vast network of observatories, working in unison to capture and interpret these elusive signals. Their shared effort underscores the incredible value of uniting brilliant minds from different nations under a common ambition: to solve the deepest mysteries of the cosmos. In the end, you come to realize that gravitational waves represent far more than a simple physical occurrence. They serve as a profound reminder of just how much remains unknown and how vast the frontier of discovery truly is. Each time we register one of these cosmic murmurs, we move a little closer to resolving the ultimate questions of our own existence and our specific role on the immense stage of the universe. What then does the future hold for this field of exploration? As we forge ahead with new technologies and refined methods of observation, gravitational waves are poised to unveil secrets that you can currently only dream of. It is conceivable that in the near future, we will witness events so extraordinary they will redefine our very understanding of physics, cosmology, and in the process, ourselves. This incredible adventure is only just starting, and every new signal is another stride toward grasping the true magnificence of the cosmos. The search for life on other worlds has been an idea that has enchanted human thought since the dawn of time. You may often wonder if another planet like our own exists, brimming with light and living things. The notion that we might not be alone in this vast universe is a deeply compelling one. When you look up at the star-filled night sky, it is natural to ask what lies beyond the familiar confines of Earth. It is easy for your imagination to take flight when you contemplate other planets. And within our own solar system, a few specific worlds have sparked particular curiosity. Mars, for instance, has been the focus of exhaustive research. Its dramatic landscape of deep canyons and towering mountains leads you to speculate whether life could have once flourished there. The thought of discovering fossilized microorganisms in its now barren soil remains a tantalizing possibility, fueled by the hope that evidence of its once liquid water still exists in frozen form. Yet, Mars is not the sole contender in our local neighborhood. Consider Europa, one of Jupiter's moons, whose surface is a thick shell of ice concealing a massive, deep ocean. this hidden environment might provide all the necessary conditions to support life. Scientists are actively investigating the possibility that organisms akin to those thriving in Earth's own deep-sea vents could be swimming in the perpetual darkness of Europa's vast subterranean sea. The exploration becomes even more exhilarating when you look past the boundaries of our solar system. The study of exoplanets, which are worlds orbiting other stars, is a swiftly advancing frontier in research. We have already identified thousands of these distant planets, a number of which reside in what is called the habitable zone. This is the orbital region where conditions are just right for liquid water to potentially exist, much like finding an ideal location on a farm that is neither too sun-scorched nor too frigid for crops to thrive. The sheer variety among these discovered exoplanets is nothing short of astounding. Among the countless planets, you'll find gas giants, rocky worlds, and others with truly fascinating features, such as worlds where crystals fall like rain, or where oceans churn with molten lava. This incredible diversity leads to a fundamental question. Does life exist on any of them? For many scientists, the hunt for cosmic signals, potential messages from intelligent civilizations, has become an all-consuming passion. Initiatives like the Search for Extraterrestrial Intelligence, or SETI, are designed to eavesdrop on the universe, listening for a transmission that would confirm we are not alone. The search for life, however, isn't confined to gazing at distant stars. We are also learning to examine our immediate surroundings more closely. Here on Earth, we discover extremophiles, which are organisms that not only survive, but thrive under the most severe conditions imaginable. From the crushing pressure of the deep ocean to highly acidic environments, these resilient microbes demonstrate that life can flourish in the most improbable niches. If life can take hold in such hostile places on our own planet, is it not possible it could do the same on others? The prospect of finding life elsewhere in the cosmos raises profound philosophical questions that challenge our very identity. Should we ever make contact, how would that discovery reshape our understanding of ourselves and our position in the universe? The concept of an interplanetary encounter is simultaneously a compelling dream and a formidable challenge. Human history is filled with interactions between disparate cultures, each providing crucial lessons and sparking significant transformations, which makes you wonder what we could possibly learn from a non-human civilization. Furthermore, this cosmic quest encourages us to reflect on the importance of preserving our own world. Earth stands as a vibrant oasis in the immense desert of space, and the urgency to protect it grows with each passing day. If life is indeed a rarity in the universe, then we have a profound responsibility to do everything in our power to safeguard the life that we know. Therefore, as we reach for answers among the stars, we must also act with a deep sense of stewardship for our home. As we push forward in this great search, the future appears incredibly bright. Space missions are constantly uncovering new secrets and broadening our cosmic horizons. Technology is advancing with breathtaking speed, enabling us to explore regions of space we once thought were forever beyond our reach. With every new piece of data, we inch closer to resolving the question that has captivated humanity for centuries. Are we truly alone in the universe? The journey to comprehend the cosmos is an adventure filled with wonder and perpetual surprise, and the search for extraterrestrial life is just one chapter in this incredible odyssey. So, the next time you find yourself looking up at the stars, consider that every question we pose and every answer we uncover not only clarifies our place in the universe, but also brings us closer to understanding the very nature of existence itself. Ultimately, the quest for life on other worlds is not merely a scientific pursuit, it is also an expression of hope. The possibility that other beings exist, with their own unique stories and perspectives, inspires us to dream and to continue our exploration. As we make new discoveries, it's worth remembering that the cosmos is a vast ocean of mysteries, and we have only just begun to chart its shores. The adventure is just getting started, and the universe still has so much to reveal. What could a vinyl record, a message sealed in a bottle, and a voyage into the upper atmosphere all share in common? Each represents a deliberate attempt to communicate, a fundamental search for connection. Within the vast and enigmatic universe, the Voyager probes have served as our ambassadors, transmitting our stories and scientific data from the very edge of the solar system. These remarkable spacecraft, launched in 1977, are far more than mere machines. They are time capsules, carrying a fragment of humanity into the great unknown. The Voyager mission was born from the bold ambition to explore the outer planets of our solar system. Can you even conceive of such a monumental journey? One that would take you through the swirling beauty of Jupiter's storms and past the majestic rings of Saturn. The Voyager probes gave us a glimpse into worlds that had previously existed only in our collective imagination. For instance, the tempests on Jupiter are so colossal that they could easily engulf our entire planet, a scale of power that forces you to reconsider the true size of Earth. However, the Voyager probes were designed to be more than passive observers. They were true explorers. With every photograph they captured and every measurement they took, they gathered priceless data on the composition and dynamics of these distant worlds. As Voyager 1 drew near Saturn, its cameras transmitted images that unveiled a realm of pure wonder. The planet's rings, those seemingly delicate strands of ice and dust, transformed into a spectacle of intricate complexity and beauty that astounded scientists and the public alike, like a masterpiece of cosmic art in perpetual motion. As the probes continued their outbound trek, they began to approach the very boundary of our solar system. In 1987, Voyager 1 achieved a historic milestone by becoming the first human-made object to enter interstellar space. To understand what this means, imagine you are on a ship in the middle of the ocean, only to realize you have sailed far beyond any familiar coastline. The Voyager probes are that ship, navigating uncharted cosmic waters and sending back information that helps us understand not just our own solar system, but the immense universe that lies beyond it. As these probes journeyed deeper into uncharted territory, they carried with them a very special message, the renowned Golden Record. This record, which functions as a sort of time capsule, is our attempt to communicate the essence of humanity to any intelligent life that might one day encounter it. Can you picture yourself as an alien discovering this golden disk drifting through space? It contains greetings in more than 100 languages, a diverse selection of music from across the globe, and a gallery of images that reflect the rich tapestry of our species. A kind of family album on a cosmic scale. Of course, the voyage of these probes was anything but easy. Over the decades, the relentless and extreme conditions of deep space have started to take their toll on the probe's systems. Yet, despite these immense challenges, both spacecraft continue to transmit data. Each faint signal we receive from them is a powerful testament to their resilience, and to the human ingenuity that brought them into being. It is expected that they will keep sending these signals for several more years, until their energy sources are finally depleted, bringing their historic mission to a quiet end. You should remember that even though these probes have journeyed to incredible distances, they remain intrinsically linked to us. The Voyager spacecraft have also been instrumental in teaching us about the environment they navigate, studying phenomena like the solar wind, magnetic fields, and cosmic radiation. This has yielded crucial data on the interaction between our solar system and the vastness of interstellar space, revealing that the cosmos is not a void, but a dynamic sea of particles and energy that our probes have helped us learn to traverse. The saga of the Voyager probes is equally a narrative of human perseverance. In the beginning, the mission's feasibility was widely questioned, but through the dedicated work of thousands of scientists and engineers, an incredible success was realized that has now endured for decades. Each new piece of information they sent back broadened our cosmic perspective and served as an inspiration for an entire generation, making one marvel at how a small team of engineers could fundamentally alter our view of the universe. A truly remarkable quality of the Voyager mission is its power to bring humanity together. Regardless of your origins or personal history, we are all united by a fundamental curiosity about the cosmos. These probes have served as a powerful reminder that, for all our differences, we are joined in the common pursuit of exploring and comprehending the universe we inhabit. At this very moment, Voyager 1 is over 20 billion kilometers from our planet. Though its voyage has been long and solitary, its legacy continues to flourish. Each signal we receive from it reinforces the idea that we are part of something immeasurably larger. We can only wonder what other secrets it might uncover as it continues its journey through the cosmos, a question that only time itself can answer. So, the next occasion you find yourself gazing up at the night sky, take a moment to think of the Voyager probes. They stand as a testament to our inherent curiosity and our drive to venture into the unknown. They have shown us that while the universe is immense and enigmatic, there is always something new waiting to be discovered. And perhaps that very fact is what makes our existence so profoundly special. The path forged by the Voyager probes is one most of us can only dream of. Yet their story is far from over. Every discovery they transmit brings us a step closer to answering the profound questions that have captivated humanity since the dawn of time. What truly lies beyond our current understanding? What enigmas are still concealed in the limitless expanse of space? As we contemplate their incredible journey, we are reminded that the process of exploration is continuous. Every advance in science and technology unlocks new possibilities, and each question we resolve leads to new avenues of inquiry. Therefore, let us persist in our quest to explore, learn, and dream, because the universe is brimming with wonders that await our discovery. The magnificent cosmos presents an unforgettable spectacle, a canvas of mysteries and marvels that compels us to contemplate our own place within it. Every star, every galaxy, and every particle of cosmic dust narrates a part of this grand story. But what is its significance for us? What is our role in this immense cosmic play? It's easy to feel insignificant when faced with the sheer scale of the universe. Yet you are a direct product of this very cosmos, composed of the same fundamental elements as the stars and planets. Isn't it a captivating thought that a piece of the universe's history resides within each of us? We are, quite literally, made of stardust, which creates a deep, fundamental connection to everything that exists. This inherent human curiosity, the very spark that impels us to probe the unknown, has driven generations to look to the heavens and ask what lies beyond. The pursuit of knowledge is a boundless journey, and every discovery simply unveils new questions, much like a labyrinth where each turn reveals new paths to investigate. Science has equipped us with extraordinary instruments to decipher these cosmic puzzles. From telescopes that peer into the deepest reaches of space, to robotic probes journeying beyond our solar system, we relentlessly push the frontiers of our comprehension. However, each answer seems to spawn a host of new questions. For instance, finding an exoplanet capable of supporting life immediately makes you wonder what forms that life might take, and whether communication with beings from another world would ever be possible. The elegance of the cosmos is found not just in its scale, but also in its intricate complexity. You can see this in the graceful dance of planets in their orbits, each tracing a unique path in a perfectly synchronized celestial ballet. This delicate balance is maintained by gravity, the unseen force that connects all celestial bodies. Yet what occurs when this equilibrium is broken? The collision of galaxies and the birth of black holes are just a few of the spectacular results of this fascinating cosmic interplay. As our exploration of the universe deepens, we encounter concepts that profoundly challenge our intuition. Dark matter and dark energy represent two of the greatest enigmas we are yet to solve. Their true nature and their influence on the structure of the cosmos remain a mystery. Though we cannot observe them directly, their effects are unmistakable, making science feel like a colossal puzzle with crucial pieces still missing. With every new finding, however, the final picture grows clearer, drawing us closer to understanding our place in the universe. The expansion of the cosmos serves as a powerful reminder that nothing is static. Everything is in a state of perpetual motion. You can visualize this by imagining points drawn on the surface of a balloon as it inflates. They all move farther apart from one another. Our universe behaves in a similar fashion, but it leads to the perplexing questions of what it is expanding into, and whether there is an ultimate boundary. These are the kinds of inquiries that will likely fascinate scientists for many generations. The search for life on other worlds holds a central role in this grand quest. The question of whether we are alone in this vast expanse inspires a profound sense of awe. Exploring exoplanets has unveiled worlds that defy our imagination, some resembling Earth and others being utterly alien. The mere possibility of other intelligent beings compels us to contemplate what a conversation with them might entail, as we continue to look for missions that expand our knowledge beyond our own solar system. Consider the Voyager probes, which have acted as our ambassadors in the vast emptiness of space. Each signal they transmit serves as a powerful testament to humanity's limitless curiosity and our inherent impulse to explore the unknown, reminding us that we are driven by a deep-seated need to push beyond our own frontiers. As this chapter of exploration draws to a close, it is vital to acknowledge that our current grasp of the cosmos is merely a starting point. Science is progressing at an incredible rate, with new discoveries and theories surfacing daily, compelling us to constantly reevaluate everything we believe we know about reality. The Chronicle of the Universe is a narrative that continuously unfolds, and we are active participants within it. Consequently, the sheer magnificence of the cosmos calls on us to continue dreaming, to persist in our explorations, and to never stop posing fundamental questions about our existence and our place within it all. While we may never uncover every single answer, the very process of inquiry and the pursuit of knowledge are what fundamentally define our humanity. Each star that illuminates the night sky is a constant reminder that no matter how immense or bewildering the universe may seem, our passion for learning and discovery must never wane. For our greatest discoveries are still ahead of us,